Good afternoon, everybody, and welcome to our workshop with Wagon. They're going to talk you through a data analytics sprint, and I am very happy to be joined by Sarah O'Grady. So, Sarah, I will hand over to you.
Hi everyone, and welcome to this data analytics webinar with Wagon, but in partnership with Athena Hackathon, which is very exciting. So welcome to you all. I'm Sarah and I'm a lecturer and developer at Wagon London, or Le Wagon, because we are a French company. We run coding boot camps all over the world. So we are in 50 cities and have over 1,000 alumni worldwide. And we have both a web development bootcamp and a data science bootcamp. So I know a lot of you here for this hackathon event on the weekend, you will have prior coding experience. So you might be interested in the data science bootcamp that we run. And if you are, then please feel free to contact us via the links that Alex or my colleague Laura will put in the YouTube channel. But let's get coding first of all, so that you can have a flavor of what sort of thing we cover. And part of our mission is to get more people into tech, and especially women. So it's very exciting to be here. So I'm just going to share my screen now. So just give me one moment. Brilliant. There we go. So that should be with you now. So we are covering data analytics, and we're going to be first of all having a Python 101, so a bit of a refresher if you already know some Python. But if you're brand new to Python, then this is perfect to get you started. And then we're going to have a look at data analytics as well. So the main thing to think about here is like get into your mind of what a data scientist does, and that's what we're going to be covering today. So we're first of all going to look at Jupyter Notebook. So this is sort of like a typical text editor that you might use. I'm sure a lot of you have used a text editor before, so maybe Atom, Sublime Text, Visual Studio Code, things like that. Or maybe you have actually used Jupyter Notebook, which is fantastic. And please do bear in mind during this, we're going to send you a link at the end of the webinar so you can practice all of the skills that I'm covering today. So we have a platform online called Learn, and we'll send you a link to that and you can log in. All you need to do is just sign up with your email, set a password, and then all of the slides will be on that link. You'll also have a recording of this from our CTO called Seb. So you can watch that back as well if you didn't catch any of the things that we covered, if I went a bit too fast. And you'll also have some challenges that you can do yourself too. So we have Jupyter Notebook on this screen here, and it looks very much like a typical software. So we've got file, edit, view, insert, cell, but this isn't really what we're interested up here. We're much more interested in what's going on down here. So we have two different types of cells. We have a code cell. So right now it's a code cell, and we can just write, say, 2 + 2. And I'm sure if some of you have done lots of coding before, this is quite basic, but we're going on to data analytics just after we do this Python 101. And the whole webinar will be about an hour and a half. An hour and a half. Let's see how we go. So we can run some code in here. And I just used a shortcut. There is this button up here that says run. So if we do another one, for instance, 3 × 8, then I can click on this button here that says run. But I can also type in some code, so 2 / 5, for instance, and I can click shift and then enter, and that runs this line of code. So that is just some basic Python to get us started, but let's dive a little bit more then into other things that we can do with Python. So let me just move this picture of me. I don't think you can see that, but I can have a little picture of myself in the bottom right-hand corner. Okay, so we're doing Python 101, and then we are doing some exploratory data analysis with pandas, matplotlib, and seaborn. So you can also use Jupyter Notebook online. So I have it downloaded over here. So this is on my machine, and I'm actually running a terminal here. So that's what I'm doing. But in the links on our Learn platform, you can run Jupyter Notebook in your browser, no problem, without downloading any software. So that's absolutely fine. Right. I'm just going to see if I can find the chat as well, because it has disappeared. There we go. Okay, perfect. We've got the chat now. Just in case any of you have any questions as you go along, Alex will inform me of any of your questions. So we've done some basic maths here, but we want to do a little bit more than just this, because Python has a lot of computational power. And we don't just have code cells, we can also have something called a markdown cell. So if I click on my next cell here, and I click on this arrow, I can change to a markdown cell. Now think of a markdown cell like a comment or instructions. So if I click on that, and then I know the different shortcuts. If you Google Python Jupyter Notebook markdown cell syntax, I'm sure lots of different things will come up. This is just going to make our text a little bit bolder, and I can just type in Python 101. And then I do shift and enter, and there you go. We have a markdown cell comment here. If I tried to write that in a code cell, because this right now you can see here is a code cell. If I type Python 101 and then run that, I get an error, because right now it thinks that this here is a piece of code. So we have not defined a variable, which I'll explain what that is in a moment. We haven't defined a variable called Python 101. So that's what it's looking for. It can't find that, so it has an error. But don't worry too much about errors. They are your friend. They do explain what is wrong with your code, so they can be very useful. So let's get rid of this cell. We have our markdown cell, and we have our code cell up here. And we can also see that when I am off the cell, it's blue. So this is an inactive cell. And then when I click into a cell, you can see here that it turns green. And this is what we call an active cell. So just be aware of that too. So now we know what Jupyter Notebook is. There's lots of different types of information that we could be dealing with. So if you've done any programming before, I'm sure you know what I'm talking about. But let's just run over this, because I know some of you at the Athena Hackathon event are new to coding. So this is more aimed at you. It will take about 15 minutes, and then we'll go on to some more data analysis. So in Python, we have some simple built-in types. We have numeric types, text types, and we have another nice type called a Boolean. So there are two types of numerical types. There's an integer, and there's also a float. Now, I'm sure some of you know the difference between these two, and it is quite simple to differentiate between the two. So let's have a go over here. So I can use something called a method, and I can use that here just to check what type the built-in type is that I'm dealing with. So if I put 8 inside of here, a type of numerical type, and then I run this cell by either clicking this button or shift and enter, then it says int here. So 8 is an integer. So if I try it again, but with a slightly different type of numerical type, and let's say 8.0, then I get back float. So the only difference between an integer and a float is that a float has a decimal place, and an integer is a rounded number with no decimal places. So a float doesn't just have to be 0.0, it can be, say, like 8.7, or you can have as many decimals as you want. And if I then just cut this and put type here, paste that in, then I still get back a float. So we've seen the two numerical types, integers and floats, and then we also have a text type. Now our main text type is called a string, and a string is just a bit of text. And so it can be a word like London, and we get back our string here, or it can be a whole sentence. So I live in London, and that would still be a string. So if I just put that inside of my type method, there we go. I get back str for string, and there we go. This is a string. So it's telling us that this object that we have here is a string. So that is our text type, and we can do lots of different things with our strings, and we can do something called string concatenation, which is super nice. So if I type a string and I just say I live in like this, then I can add two strings together and say London, and I get back one big string. So you can add strings together like this, and it's called string concatenation. And finally, we have a type called a Boolean. And a Boolean is a yes or no type. So imagine you want to ask the question, is it raining today? It's a very simple answer. The answer is either yes or no. And a Boolean is reflecting this yes/no type. So instead of yes and no, we use the words true and false. And so if you've done other languages, this is really similar. And in Python, we write them with a capital letter. So true is true. And if I put that in our type function, there we go, I get back bool, short for Boolean. And then we also have false as well. And that is also a Boolean, just like that. And just be aware that if you do it with a small letter, do you see how it's not turning green like this false word is? So this is actually not a Boolean. So you do need to always remember to type it with a capital letter. Otherwise, you'll get back an error. And once again, our code is looking for this word as a variable. And we're about to get onto variables in just a second. So a nice thing that you can do with Booleans, just before we move on, is that you can use them together. So you can say true and false, for instance. And if you say true and false, you have them together, then what we're looking at is this side of the and true? Yes, it is. And is this side of the and true? No, it's not. And we're using the word and, so it's checking to see if both sides of the and are true. It's not, so that is going to return false. Whereas if we do a similar thing, but use the keyword or, so we say true or false, then we're checking to see if both sides are true. But this side is true, this side isn't true. But because we're using or, only one side needs to be true. So if I run this code, then I get back true because only one side of the or needed to be true. So the answer is true. And the final thing I just want to show you with Booleans is you can also say not true, which I'm sure you know what that would return. And it would return false. Okay, so I want you to have a little think. And I know that there is a slight delay in the chat, but just have a think about this. I won't be able to see your answer, but you have a think and ask yourself, what is the type for a street number, a zip code, and annual income? So they're similar sorts of things, but they're going to have slightly different types. And it will depend on who your clients are, who your customers are, whoever you're dealing with, as to whether if you were running a company, you would want this type in your database to be a string, a Boolean, an integer, a float, and you'd need to define this column in your database as a specific type. So you've had a little while to think. So let's take street number first. And let's just put this as a markdown cell. So to the shortcut for a markdown cell, instead of clicking on markdown like this, there's another thing I can do, because we're lazy as developers. Developers are usually very lazy people. We love shortcuts to anything. And I can just hit the M key, and you can see that that changes to a markdown cell here. So if I put this in street number, what do we think a street number is? Now, if you think about this in terms of London, I live at 133, so that would be an integer. However, if you think of all the different flats that you can live in across London, you might live in, say, 55A, 55C, something like that. So a street number, if it was an integer in our database, then 55C, if someone typed that in, it would throw an error. And we don't want that to happen. So to be inclusive, a street number is actually going to be, if we're in London, now this might not be the same for all over the world, if you're tuning in from different parts of the world, but in London, we would need this to be a string to be inclusive. Okay, the next one that we had was a zip code. Now, zip code sounds American, so let's start off with that then. I'm not liking this arrow. Let's get rid of it and just use a colon. There we go. Okay. Oh, a space. Perfect. Okay, so we have a zip code now. So if we were in America and we had a zip code, now I'm sure if any of you have been to America or you're tuning in from America, you know that zip codes are with numbers. So just integers. So then a zip code in America, the USA, could be an integer, and that would be fine for your database. However, now imagine that you're going global with your company, and again, you want to market your company, you want to market your business in the UK. Now, our zip codes are postcodes over here, and a postcode can be something like SE11. So here we would have both letters and numbers. So a zip code, if you want this to work globally, would also need to be a string. Okay, and finally, we have annual income. And I'm sure by now you can see that you've really had to think about these. It's not always going to be the first answer that comes into your mind. So annual income, what do we think then? So annual income, if you take into consideration that you have your overall amount that you're earning each year, fine, but that's probably an integer and a rounded number. However, if you think about tax deductions, maybe you're getting a bonus, lucky us if we are, that would be fantastic, then it's going to come out as something with pounds and pence or like euros and cents. So this would actually, instead of being an integer, we would need it to be a float. If that is your income, you know, after doing your tax deductions, it would definitely need to be a float. It would be very unlikely that it would come out as a nice round integer. Oh, I didn't make it a markdown cell. Perfect. So nice one if you got those right. You are thinking on your toes, which is fantastic, and you've really thought about the problem that we have at hand. So now we're going to move on to variables. Again, variables, you come across variables in all sorts of different languages, such as like Ruby, JavaScript, and also in Python. And think of a variable like a very important box that you store information in. So here we've created the storage box called city, and inside of our storage box we're storing this string Paris. So we say we've assigned Paris, the string, to the variable city. So you sort of explain it backwards when you're using the technical language. So we can do that over here, and instead of just writing London as a string as I did above, I can write city equals London. And when I run that cell, nothing happens because all I've done is assign this string to the variable city. And then I can do something really nice, which is use my string concatenation again. So I live in, and I can add that to my variable instead of having another string there. And what I get back is, again, one big string like this. So variables are very useful. If I wanted to use this variable London in lots of different places, I wouldn't want to type out London lots of times. I could just have one variable and type city everywhere that I needed it. So we've seen some built-in types, we've seen variables, and now we want to have a quick look at functions before we dive into data analysis. So we have some built-in functions. If you've not done Python before and this is your first time looking at Python, I would definitely suggest that when you get started or when you go to our Learn platform to have a go at doing the different skills that we cover today, that you also have a look at this web page, which is a link in the slides. So again, that is on our Learn platform too. And have a look at what functions already exist, because you don't want to be building a function for your website or for your algorithm that you've created or your model. You don't want to be creating a method that already exists. So for instance, I'm sure you can already guess what sum does here, but we could just go have a look, and it gives us a nice little explanation. It gives us another option of something we might want to use. So you always want to be looking at this Python documentation. We can just go back to the very beginning. This Python documentation as you first start out learning Python. And like I said, it is a link in this slide here. So I know that you might not have done Python before, but I'm sure you can guess what this function does. So they're not rocket science, they are based on English. So we can take our city, for instance, and try out using our function len that we know is built into Python, and put our city inside, and we get back the number 6, because what len does is check how many characters there are, checks what the length is of our string that is stored inside of our variable city. So we get back 6 because there are 6 characters in London. Perfect. So there are built-in functions, and then we can also call methods or functions on a variable. So sometimes we say functions most of the time, but you can also use the word method, and methods also and functions come up in Ruby, JavaScript as well. So what we've done here is you take your string, you've stored it in a variable name, and then we're calling the function capitalize on our string name. So let's have a go at doing that then. So we can say city.capitalize. And if we do that, we get back our string London, but now it is nicely capitalized. So you're probably wondering why I was doing it in lowercase all along, but now I've shown you that you can then change your string to be capitalized if you want to by using this function. And finally, one more that you can use is this ends with. So if I just copy that and I say city.ends with, I'm sure again you can guess what this function does. If I run this, I'm going to get back a Boolean. And the Boolean that I get back is false because London ends with an N and not an S. So of course, if I then put an N inside of here and run that, I get true. And just one thing to note is that if I put in a capital N and run that again, I get back false because London is with a small n and this function is case sensitive. So that is one thing to bear in mind when you are using any function. It might be that the function is case sensitive, so you might need a workaround for that. Okay, so we've done a whistle-stop tour of Python. We've seen functions, variables, and different types in Python. And now we're going to move on to data sourcing. So before we do any of the fancy modeling, AI, anything like that, any data analysis like we're going to be doing today, we need to actually collect or source our data. Now, I do realize that we're going quite fast through this, and if you've never done Python before, that was very quick. So you're going to have access to all of the slides at the end of this on our Learn platform, so you can go back through everything we've looked at if this is brand new information to you. If it's not, then I just wanted to do that quick recap so we can get on to the data analysis now. So about 80% of a data scientist's job is going to be cleaning data. So we're going to get onto that in a second. We're going to source our data first, then we're going to clean it, which is a really important job, as you'll see, and then we're going to analyze our data. So let's look at where we can get our data from. So different companies that you work for are going to be using different software. And you can export your data from a CSV, for instance, and that's what we're going to be focusing in on today. So we're going to be using a comma separated value file, CSV for short, to store our data, and I've downloaded it from a website, which we're going to show you as well. It might already exist on a database somewhere, so that's your company's database, for instance, or on a server, or you can get data from a website online, and I'll show you some good examples of websites you can use for this as well. Or you might use an API to get your data from there. It might be that you're not really sure what an API is. So just a brief summary of what it is it's a software interface that helps interaction between and an API has endpoints that we can ask for information from, and then you get a response from that API, often in the form of something called a JSON. So if you're interested in APIs, I definitely recommend you look them up and see how they work. But we also do webinars on that. So if you wanted to come to one of our Wagon webinars on APIs as well, I'm sure there's one that's coming up in the future. You can just go to lewagon.org/webinars or events. Have a look on the website, or maybe my colleague can put that in the chat for you on YouTube as well. And finally, you might receive data by email. It is less likely, but it is a possibility. So what form is our data in? So I just mentioned that we might have our data in the form of a JSON. It might be a CSV, which we'll have today, or it might be more unstructured data like a PDF document, a TXT document, or it might be in binary. So this is more likely if you're working for a big company that encrypts its data and you would need software to open it. So it's not something that you could just read yourself. It's very unlikely that you'd be able to just read binary. And it would be very time consuming, even if you could. So you need some software in order to decipher it. Okay, and data is online. So what's happening when you have data online? You have, for instance, an SQL database that you have access to, and you can get your data from a website using SQL or SQL for short, or you might have your data in Google BigQuery or another data warehouse. So a common one that you might use for your company is Snowflake. That is a big data warehouse, and that uses SQL too. Or you might have an API and documentation that you use to get your data, or use web scraping. But just be careful with web scraping because there are some laws around it. So it depends which country you're in as to how legal it is. So be careful with web scraping. Just look up the rules and regulations in the country you're in. So where have I found my data set that I'm about to use? I've actually got my data from Kaggle. So let's have a look at Kaggle first of all. Again, I'm just going to move this little bar that you can't see at the top of my screen. Okay, so Kaggle was created as a company. It formed in 2010. So it used to be a startup, but you wouldn't consider it a startup anymore. because it is now a huge community of data scientists. It started off by having competitions around data science and discussions in a forum on data science as well. And it really exploded in terms of its user base. So then Google ended up buying it. So now really it's a very big entity. It is still, as you can see, it keeps its marketing the same. So it's still Kaggle, but it is part of Google. And on Kaggle, you can search for different types of data. So if we search for some restaurant data, for instance, we get back lots of different data sets that we could have a look at. So if we just look at Zomato, for instance, nice. And we've got a context of where this has come from. We can see that it's a CSV file that we'd be downloading, a little summary here. And then we have the columns actually that head up our database. So book table, rating, votes, phone. So you get a nice little overview of the data that you have. We have 17 columns here, and you can see the different types that the columns are as well. So that's Kaggle, and I'll show you the data set that we're using in a moment. And then there is also another nice one is Google Dataset Search. So if we just go on here, and again, you can search for data in the search bar, or you can click on one of these frequently searched for options below. So if we look at education outcomes, it's got different data sets down the side. So over 100 data sets that we could have a look at. You can just have a bit of a browse. High cost of low educational performance. That looks quite interesting. And it shows you where you can get that data from. So it gives you different links to where you can find different data sets, which is super nice. And from lots of different countries, lots of different backgrounds. So there you go. If you want to have a try at analyzing some data at home, then you can definitely use Jupyter Notebook in the browser, which there's a link to on our Learn platform, and you can just have a search using dataset search or Kaggle for a dataset that you personally feel connected to, interested in, and explore your dataset. So we are going to be using Pandas. So Pandas is a really great tool. It's also a great animal, but it's a tool that we're going to be using, and it's a library built on Python. So if you wanted to download it onto your machine, then you just go to this website, and there's a link in the slides that you can use, and you just click on install Pandas now. I already have it, so I'm not going to do that. And the whole purpose of Pandas is it was created to ease data analysis. So ease data analytics. So it's a really good tool. And there's also lots of information on this website about Pandas if you wanted to have a look at it. So like getting started, it shows you how you might install it, or some frequently asked questions as well. So that is Pandas. So you might be asking yourself now, why are we not going to use Excel? Now, a really good example of why we don't use Excel is actually the coronavirus track and trace app in the UK. Now, I don't like to call people out, but I'm going to anyway. The reason why they had a big crash of the app at one point was because they were using Excel, which is just nuts to even think about. But Excel actually has a limit of 1 million rows. So if you're dealing with a population of 7 billion people, you're going to hit that limit of rows very quickly. And so although Excel does handle large data sets, it doesn't have an unlimited amount of rows. So Pandas has much bigger computational power. It doesn't have this 1 million row limit, and it's quicker and more efficient. So that's why we're going to be using Pandas. It can also combine multiple files. So you might have a CSV, a JSON, an Excel spreadsheet, and you can merge all of that data together. So you can use it on the same page, for instance, your same Jupyter Notebook. And you can also get information directly from APIs. And then finally, it uses Python, which is by far the best programming language, but I'm probably biased on that. So I'd be really interested to know what you all think is the best programming language. So why don't you have a discussion about that too? So this is how we're going to use pandas then. So we're getting onto the data analysis in just a moment, and this is how we're going to use pandas. So we're loading data directly from our CSV file, which I have pre-downloaded from Kaggle, and we need to import pandas. So we say import pandas as PD. So the convention is to shorten this long word pandas. I guess it's not that long, only 6 letters, but we shorten it to PD so we don't have to keep repeating ourselves. And I'm sure if you've done some coding, there's this concept of keeping your code clean and dry. And dry stands for do not repeat yourself. So you don't want to be typing pandas out a lot. The shorter you can write your code, the better, the cleaner it is. So we're using pandas, and then we're using this built-in function read CSV, and then we give the name of the file path that we want to use. And we're assigning all of this data that we've loaded to something called a data frame, or this is also a variable here. And we're storing it inside of this here because we've got a single equal sign, and a single equal sign is assigning something to something else. So it doesn't mean this equates to this. It means assign this to this. And if you wanted to use a different type of data, just let that load a second. There we go. You don't have to use just read CSV. You could use read JSON if you're using a JSON, read Excel if you're using Excel. And then also you have binary options at the bottom and also SQL options here. So read SQL, read GBQ. Okay, so that's a nice link as well if you wanted to have a look into that, if you've downloaded a data set from Kaggle that isn't a CSV file. And then we're also going to be using Seaborn for data visualization, and it's based on matplotlib, which is another Python library. And the convention that we used here is import Seaborn as SNS. So SNS is our shortened version of Seaborn. It's not something I've made up. This is convention, so please do follow it. Technically, you could write whatever you want here, like banana, and then if you use banana later on in your code, it would be referring to Seaborn. But this is the convention, so we follow the convention because we're good developers. Okay, so we need to have a look at our data set first of all. So this is the data set that I'm going to be using for the data analysis, and it's the New York City Airbnb open data set. So if I go on this, it takes me to Kaggle. Like I said before, we're getting our information from Kaggle, and I can already see an overview of our data set. So it's since 2008, all the way up to 2019 in New York City. We've got a CSV file here. You can see it's 7 megabytes there. And we have our columns here. So ID, name, host name, neighborhood group. So we need to have a look at what this is. But you can see some fields here: Manhattan, Brooklyn, a smaller neighborhood, latitude, longitude, which we'll be using later on, and room type and price, which is going to be very important for us. And actually, we have this summary here. We've got 2 files we could possibly download and 16 columns. So we already know a bit about our data, and now we want to actually crack on and use it. So I'm just going to copy this here, and we're going to jump into Jupyter Notebook, and we're actually going to do some data analysis. So the first thing that we're going to do then is create a markdown cell so that we signpost what we're about to do to anybody that's reading this document. And we're going to say data analytics. And we need to, first of all, import pandas. So remember our convention, we're going to say import pandas as PD. And if I run that cell with Shift Enter, you can see it says 84 here. whilst it's thinking, I don't know if you've noticed, but a little star comes up. And then once it's run it completely, it will say 84. And if there's any problem with it, if there's been a problem with the download of pandas or anything like that, an error message will pop up. So there's no error message, so that's fantastic. We can crack on. So actually, if we just have a quick look at what I have access to, I can type ls, which is a terminal command. I have my terminal running here, and I'm inside of a folder, and I can see that I have this live code Jupyter Notebook file, which is what I'm in now, and then I have this folder data as well. So if I show you here, I have data and live code. If I go into data, this is where I've stored my CSV file. So this is on my computer, I've downloaded it, and it's saved inside of the folder data. So I'm going to create a new data frame. And if you want to read more about data frames, there is this link here on the slides. I won't go too much into it now, but it's essentially like we've loaded from pandas our data set. Think of it a bit like an Excel spreadsheet, but just much better. So I'm going to call it listings df. df, again, is the convention. It's a data frame. So I'm just tacking that onto the end. And I'm going to say PD, because we've loaded pandas, and say read CSV, and then I need to put my file path. Now I need to put the whole file path because I'm inside of this data folder, and then I want this file. So I think I copied it from the slide. Yeah, there we go, I did. So we want the data folder, and then we say the name of the file. So if I run this, I have no errors, so that's good. So I've loaded up my data, which is fantastic. And we did see a preview of it on Kaggle, but I actually can't see any data right now. So let's do some data analysis. So we're going to take a quick look at our data frame first of all, because all we've done so far is assign it to a variable called listings_df. So let's have a look. I mean, we do have some information about our data frame because we saw it on Kaggle, but we actually want to see some of our data. So I'm going to call some of these methods that were on the other side, on the slide, sorry, the other slide that I was just on. So if I say .shape, first of all, then that gives us back two numbers. Now we've already seen this number 16. We saw it on Kaggle, if you guys were paying attention, which I'm sure you were. So 16 is actually the number of columns that we have. So if 16 is the number of columns, then 48,895 is going to be the number of rows. So we have almost 50,000 rows, which is a lot of data, but nowhere near the amount of data that we could store in this data frame if we wanted to, and 16 columns. So we have a little bit more information. I'm just going to copy listings.df here so I don't have to type it out each time. And now I want to see what actually the column titles are. So if I run that, I can see that we have ID, name, host ID, and this was all stuff that we saw on Kaggle too. So this is fantastic. We already knew this information, but we can see it in Jupyter Notebook if we want to as well. Now, what we haven't seen yet is what the data types are of each column. So the function that I can use is called dtypes on our data frame, and I get back all 16 columns again, and then next to those 16 columns, I have the data type that they're going to store inside them. So just like before when we were talking about annual income, the zip code, and the street number, here we are saying what the data type is next to the column name. So ID obviously is going to be an integer. So it's going to start from, actually it's going to start from 0. So that's one thing definitely to note, that all of our numbers start from 0 in programming. That's very common in Python. That happens in some other programming languages such as SQL, you start at 1, but in Python we will be starting at 0 in terms of indexes. And then our name of our Airbnb is going to be, here it says object. Just think of object meaning string for now, so this is referring to a string. Then our host name is also a string. So we have a little bit more information now, which is super handy. But we haven't really seen any of the data. So let's take our data frame and we're actually going to have a look at some of the data. So if we run this now, then we get back the first 5 rows in our data frame. And you can see here it starts at the index of 0 and goes all the way up to index 4. So by default, head, this function called head, it takes the first 5 rows. If we wanted to get the first 10 rows, then all we need to do is put the number 10 inside of the parentheses, and then we get back the first 10 rows, so rows 0 to 9, because we're starting from 0. And now we can see the different host names, the neighborhood group, what that contains. So we're getting more of a feel for our data. So it's always useful to do this if you're dealing with a new data set. This is the type of thing that you're going to want to do. And the last one I want to show you is called tail. So I'm sure you can guess what it does. If head takes the first 5, then tail, by default, is going to take the last 5. So we know that we have 48,894, 95 different listings. Because we start from 0, it goes up to 94 here. And we can see the last 5 rows. Now, if I scroll along here, these are going to be very interesting fields for us. So you can see that in this last review column, I have something called an NAN. Now, this is going to really screw up our data. Look how many NANs there are. There are 10 just in these 5 different rows. So what I need to do is now move on. Now I've got a feel for my data. I need to move on to cleaning the data. So how can we clean the data a little bit? I want to first of all see how many NANs we have in our data, because that's really going to throw a lot of errors if I try and manipulate data with NAN fields in them. So the reason why you might have an NAN is if you say do 0 divided by 0, that doesn't come up with a number, so it's come up with not a number. That's the only reason why. Or if you have no information submitted to that field, then you'll have an NAN in there as well. So I'm going to run this line of code to sum up how many NANs I have for each column. So I can say dot is null, and then don't forget these parentheses, and then dot sum. So I'm adding up the null fields for each column. So there you go. You can see that the name column has 16 NANs, the host name has 21 NANs, and then last review and reviews per month have over 10,000 NANs, which is really going to cause a problem for us. So we either have wrong information there, missing information there, and Pandas is going to really throw a hissy fit if we try and manipulate that data in any way. So we're either going to get rid of it or we're going to change it. So we're going to look at 2 different ways of doing that. So the first thing that we can do is drop some of the columns we do not find relevant enough for our analysis. So let me show you how to do that first of all. So what we're going to do is we're going to create a variable. So I'm going to call it columns to drop, and then say columns to drop, and our columns that we want to drop, just going to pop them in here. So the ID, we don't need the ID, so let's get rid of that. The host name, we don't need that, so let's get rid. And then the last review, I also don't need that, so I've got rid of that too. Well, we're about to get rid of that too. So these are just the columns in something called a list. So in the square brackets, we call that a list. And we've assigned this list of strings to the variable columns to drop. And now what I'm going to do is I'm going to take my listings df and I'm going to tell it that I want to drop. So I'm going to use the function drop and give it the variable that I have on the line above. So columns to drop. and then say that the axis that these columns are on are obviously columns. And the final argument that I need in here is in place equals true. So what this final argument does, in place equals true, it says that I want to permanently do this. So I don't just for this cell want to drop these columns, but I want to permanently drop these columns from my database. So let me just check my code. That looks okay. So I've run that. And now if I rerun this line above, so see the sum of all the NANs that I have, then I should have fewer NANs. Yeah. So we got rid of ID and host name and last review, and none of those are here now. So now I'm just left with name and reviews per month that I need to deal with. So we've got another way that we can clean up this data, and we can do it by replacing NANs with more relevant data. So we can use the function fill NA, and we say the name of the column we want to fill, and because reviews per month is just the sum, the total of how many reviews there are. If the reviews are 0, if there are no reviews, then the reviews per month is also going to be 0. So we can replace the NANs with 0 and again say in place is true because we want to do it permanently, not just for this cell. So if I take my listings DF, I'm just going to copy that for later. And then I say that I want to fill NA. And then I do my brackets, and then I need a dictionary. So these curly brackets here are called a dictionary in Python. And I'm going to say reviews per month. And I want to replace that with 0. So the NANs that are in the column reviews per month are now going to show up as 0 instead. And then say in place equals true. Now, if I just check my code, that looks good. If I run that, and now I run this line of code again, the reviews per month column should now still be there. It's still going to be there, but there are no NANs. So this looks so much better. I'm going to leave the name here because we're not really going to use it, but we could delete that too if we didn't need it, but it is nice to have. So we'll just leave the 16 of those. They're not really going to mess up our data. So we'll leave it like that for now. And now we have nice, clean data. So that's it for like simple processing. But what we want to do now is zoom in a bit more on our data. So filter our data a little bit more. And there are different ways of doing this. So the first way that I'm going to show you is filter by columns. So we can focus in on a specific column. So name, neighborhood group, or price. And let's do that here. So we just going to take the listings DF. And I'm going to focus in, on the column name. And if we do that, you can see here, I get back a series. So this is called a series. It's very similar to a data frame. It's just a little bit smaller and not as nicely formatted. So if I want to get back a data frame, I can just put in another set of square brackets. And you can see that now it's a data frame with the same information. So that's just a sneaky trick. And we have just the sort of row position that it's in and the name. If I wanted a bit more information in here, I could also say that I wanted the price. And now I have 2 columns, just the name and the price for every single row that we have. So that's if I wanted to focus in on specific columns, but I can also focus in on specific rows. And we do that by using the index. So let's say I wanted row 5 to row 10, then I can take the listings DF and I can use the square bracket notation and say 5. And actually, if I wanted to go all the way up to row 10, I would need to say 11 here. So this is not inclusive of the number that you put. So if I run that, you can see it starts at 5, index 5, and goes up to index 10. So it's not inclusive. Just bear that in mind when you're using this notation. So the final thing that I want to show you about zooming in on columns and rows is that you can use this notation together. So if I actually just take this here, so the name and the price, and let's just say that I wanted to focus in on name and price, but just rows 5 to 11, then I can do that and I just get the name and the price for indexes 5 to 10. Perfect. So all the slide is telling you is that we can actually combine both approaches. And oh, there wasn't an example there, but you just put this, and then at the end of this, you would put this notation as well. So you can add them together and combine the approaches. Okay, so now we're going to have a look at something called Boolean indexing. So this is, again, filtering our information even more. So imagine that we're going to go on holiday. So we're going on holiday and we only want to get back the listings on Airbnb that are within our budget. So have a think about how we're going to do that. I'm just going to grab a sip of water so I don't have a really dry throat. It's just over here. But if we're going on holiday, we're going to want to type in, say, £100 and only get back the listings that are £100. So the way that we can do that is by using this notation. And we say listings DF, we want to focus in on the column price and then give a condition to our data frame. So let's have a look at that. So we take our listings DF, we wanted to focus in on the price and then say our budget is £100. We only want to see the listings that are less than £100. Now, you might think that this is all we need to do. However, if some of you have used Boolean indexing before, you'll know that what we get back is actually every row with then a list of false or true. So if we get back the answer false for a row, it means it's over £100, and if it's true, it does match this condition and it's under £100. But what we want as a user is just to see the flats that we can actually afford. So what we can do is take this condition and give it as an argument to our listings data frame. And if we now run that, you can see before we got back all of the rows, but now when we give this condition to our listings DF, then we get back 21,877 rows. So a lot fewer rows, and we focused in on that data. Okay. So we did this with Boolean indexing. We only got back our flats that are less than £100, which is great. That's what we wanted. And now we're actually going to ask our data set some questions because we've taken the data, we've had our first look at it, we've cleaned it up, we've updated some of it, and now we actually want to get to the bottom of some of the questions that we have about our data and visualize it as well, because we haven't used Seaborn yet. So we want to make sense of it, make it more tangible, and perhaps actually present this to people as well. So I'm going to be asking a lot of questions to our data set. So the first question is, what are the 10 most reviewed listings? Now, I am going to be using some things that we've already seen, but for this specific question, we're going to be using a function that you haven't seen yet. So this, I know what it is, but if you don't know any Python, this would be the moment where you go onto the Python documentation and have a look at what functions exist to see if you can get to the bottom of this question. So we're going to create a markdown cell and do a couple of hashtags to make it bolder and say, what are the 10 most reviewed listings? So we're going to take our listings DF, and then I'm going to call a function on this, and it's called nlargest, because We're then going to give it an argument to tell it how many we want. So we want the n largest. In this case, we want 10. So I'm going to say I want 10. And we want to focus in on number of reviews, which is why we didn't get rid of this column. We wanted to keep it so we could ask this question. Brilliant. So we get back 10, and you can see that they're actually in an order. They're not in chronological row order. And if we go over to number of reviews here, you can see that this is the most reviewed listing at 629 reviews. And if we scroll down, the 10th most reviewed listing is 480 reviews. So we really nicely have the top 10 most reviewed listings. So let's ask our data another question then. So all of this is in the slides. So if you wanted to test out all of this afterwards yourself, you 100% can. And the link will be in the chat on the YouTube live situation where you guys are all watching this. Okay, so what are the New York neighborhood groups with listings? Let's create another markdown cell and have a think about this question. So the New York neighborhood groups with listings, we want to know the neighborhood groups. So these are like Manhattan, Brooklyn. We saw that on Kaggle when we saw the summary. Now we want to know what they all are. Now I could scroll through, or I could Google it probably and find out what the big neighborhoods of New York are. But imagine there's some missing data. We don't want to just assume that they're all there. So we can actually ask this to our data frame. So we can say listings df, and then we focus in on the neighborhood group. Oh, I think my R key is a little bit sticky, so please excuse that. And we're going to use a built-in function called unique, which is a really nice way of checking all the neighborhood groups and only taking it out once. So if it's repeated, 50,000 times, well, probably not that many because that's our whole data set, but say 10,000 times, then it's just going to pick it out once. So what we get back are these 5 neighborhood groups. So Brooklyn, Manhattan, which we already knew because we saw that in the summary on Kaggle, and then Queens, Staten Island, and Bronx. Brilliant. Just as we expected, which is always good, but we want to check that our hypothesis is true rather than assume that it is. Okay, so a follow-up question to that is how many listings are there per neighborhood group? So we can definitely answer that. How many listings per neighborhood group? Now we're going to be using something that you haven't seen before again, but it's a really, really nice function that is inbuilt. So we take our listings df. What do you think we're going to focus in on? Well, it says neighborhood group. So let's take this here. We want the neighborhood group. And we're going to use a really nice function called value counts. And what that does, it returns this series here, and it takes all of the neighborhood groups, the 5 neighborhood groups that we got above, and counts how many times they appear in the database in the column neighborhood group. So 21,661 rows in Manhattan, or listings in Manhattan, and just 373 in Staten Island. So this is really useful information for us because these are the questions I wanted to ask my data set, and we're managing to answer them all. So next question, what are the top 10 neighborhoods with Airbnb listings? The top 10. Now we've thought about that already, but we already did a top 10 if you're concentrating before, which I'm sure you all are. So we did a top 10. So what are the top 10 neighborhoods with Airbnb listings? What could we use? Now we definitely want our listings DF. And this time we're not looking at neighborhood group, we're looking at neighborhoods. So these are the smaller neighborhoods that exist in the bigger neighborhood groups. So we want to focus in on that. So we can say neighborhoods. Neighborhood is the column name. And then we want to use, again, value counts, because that puts them in this nice order, as you can see here. And if we just run that, look, I can show you what happens if we just run that. So you can see here that there are 221 neighborhoods. Now, it might be useful to do this step by step, this one, because we didn't actually know how many neighborhoods there were. So now we know that there aren't just 10 like we might have hoped. We now need to get the top 10 of these. And I'm sure you can think of a way that we can do that because we already used this function earlier, and we can call head and then just put 10 inside of the brackets, and we get back the top 10 neighborhoods with Airbnb listings. And this is called chaining methods here. So that's the technical term for this. We're chaining methods together. Okay, so we've asked some pretty nice questions, but now we actually want to visualize our data and use this function plot, which is using matplotlib, which is a built-in Python library, to plot a bar chart. So let's take this. Yeah, we can take the top 10. And then we're going to say dot plot. And just, we want to say what kind we want. So if we say plot, sorry, bar. I already typed plot. Okay, so then I get back the top 10 neighborhoods. So it's just all of this information that I had here, but plotted nicely in a bar chart, which looks super nice. Now, just for the purpose of showing you how Seaborn can work really nicely, I'm going to change this to neighborhood group, so we have slightly less data. And let's take out this top 10. And if we run that, right, now we are just dealing with 5 bars rather than 10. But you can use whatever data you want. But this isn't the nicest looking chart that I've ever seen. So we're going to try and create the same chart, but let's use Seaborn. So we haven't used Seaborn yet, but Seaborn is created specifically for data visualization. So let's use it. So we're going to go back up to our imports that we made before, where we did our pandas import. We want to keep all of our imports together, and we can say import Seaborn as SNS. And if we run that and go back down to the bottom, then we can use SNS and say SNS.countPlot. So we saw plot before. Now we're going to see count plot, and we can say our data equals the listings df, and we want on the x-axis, we want to plot the neighborhood group. Okay, so we get back this much nicer looking graph with different colors, so it's a bit more visual. You know, you don't just have these blue ones, but what we don't have is them in order. So if I want to have them in order, then what I need to do is give this Seaborn count plot that I've created an order. And I can do that by creating a variable and say to my listings df that I want to focus in on the neighborhood group. And then I'm doing the value counts to put them in number order, because you know that value counts goes from the most to the least. And then from that, I'm just taking the index. So I'm just going to copy this just to save time so we don't overrun on time. And I'll put this up here. And then I'm going to use this. Let's call this ordered neighborhoods. Okay, and I'm going to use this variable and give it as an argument inside of my count plot. So if I say order equals this variable that I've created, and then I run that, now, as if by magic, I have them in order. So if that was a bit quick, don't worry, it's on the slides that you're going to have access to. And you have the variable here, ordered neighborhoods, and we've just given it as an argument here. Perfect. So we've answered our question about neighborhoods, and we've looked at it visually as well. So we haven't actually had a look at room type yet. So now let's have a look at the influence of neighborhood group on the room type. So you've actually already seen this nice function before, which is .unique. So the first thing we need to do is actually check what the different room types are before we can answer this question. So what's the influence of neighborhood group on the room type? Of course, we need to know the room types first. So let's create a markdown cell. We can do the hashtags to make it bolder. And we need to, first of all, take our listings DF, focus in on the room type, and then we're going to call .unique on this. And then we get back 3 different types of rooms, which I'm sure we could have guessed, but now we know for sure that there are 3 types of rooms. And then we can take this here, this line of code that we have here, and let's keep our nice order as well. And we can give it something called a hue. So we can say hue equals room type to see what effect the room type has on the neighborhood group. And there you can see that CountPlot has made this really nice graph for us, and it's separated out the different room types. Manhattan's still first because we have the most listings in Manhattan, but now we can see that Manhattan actually has the most entire homes or apartments, but Brooklyn has more private rooms than Manhattan does. So this might be really useful information to our, I don't know, our sales department, for instance, for getting more. You would want to market more material to hosts in Manhattan who own entire apartments, and slightly different information would be marketed in Brooklyn, for instance, where there are more private rooms. So that might be information that your company wants to know. Okay, so now let's have a look at what is the distribution of flat prices. So how many, like, what are the flats, what's the pricing over like from 0 to like, how many pounds are we putting on our flat for? Is it £10,000? Is it £500? We want to see the distribution of the prices. So the way that we can do this is by using Seaborn again and using distplot. So we've seen CountPlot, we've seen just plot by itself, and now we're going to have a look at distplot. So let's take our Seaborn and call distplot, and then we're going to take our listings DF and focus in on the price. Okay, now you can use histplot because this is going to be removed in a future version, but just for this webinar, let's just ignore that future warning because we can still use it for now, but it will, you can use histplot instead if you come across this problem in the future. So you can see, because somebody has put on a flat at £10,000, our data is really bunched up over here. So what we want to do is actually get rid of some anomalous data. And we can do that by using the Boolean indexing that we talked about when we were going on our holiday. So we can say, let's create a new data frame, which is going to be our, it's going to be taking away our anomalous results, and it's just going to be our data frame without any anomalous results. And we're going to take our listings, DF, and then we need to give it a condition. And we said listings, DF, and we wanted to focus in on the price. And our condition is that it wants to be less than or equal to, let's say £500, because around here is about 500. Okay. So if we now run this same distplot, but let's use our affordable DF instead, so slightly more affordable flats than £10,000, affordable DF. Now we get a much more zoomed in distribution that we can actually do some analysis on. And what we can conclude is that we have some peaks and troughs, and the peaks are around here is about 150, and here is just before 200. And that's probably just before 152. So what a lot of people do on Airbnb is put their flat on at about like £199 or £149 to come across as slightly cheaper than a rounded number. So that is a nice trend that you can spot from looking at the flat price distribution. Okay, so this is what we just did. We gave a condition here, less than £500 to our data frame, and then plotted it on a graph. So you can have a go at this at home as well later on after the webinar is done. And this here would just be finding the mean, but that's not so visual, so let's leave that for now. So now let's have a look at the distribution of flat prices based on the neighborhood group. Now, this is by far my favorite part of this data analytics webinar. So let's have a look at this. We want to see the distribution of the flat prices. And what you can see is we're using this really cool thing called violin plot. Now, if it was up to me, I would just show all data as violin plots because I think it looks really cool. So let's use our affordable data frame again. So we're taking out the anomalies. We're focusing on the neighborhood group, and we're also looking at price. So we can say SNS for Seaborn, violin plot. We want to call violin plot. And then we're saying our data is our affordable data frame. And then the x-axis is the neighborhood group. Yep, no spelling errors. And then finally, the y-axis is the price. Perfect. And boom, our beautiful violin plots. Now, these aren't super big, but they are very cool. I mean, they slightly look more like cellos, but that's fine. But what we want to do is make them slightly bigger. And the best way to do that is to use PyPlot. So if we want to download, we want to import something, we want to go all the way back up to where we did our imports. And I'm going to import something called PyPlot as PLT. And I need to rerun. What did I do? Import PyPlot. Oh, I forgot something. You need to say from matplotlib, import PyPlot as PLT. So you can see here it says no module name PyPlot, which is a really useful error. So don't be afraid of errors. I make about, 10 errors a day. You just read the error messages and just rerun the cell. There's no error message now, so that's all good. So we're importing something from matplotlib. And then what we can do down here is just change the sizing. So I can say PLT, and I know all of this because I've done this before, but if you don't know, then you can have a little look on the Python documentation and say fig size equals, and I want it to be 15 and then 8. And if I run that, my violins are much bigger. They look way more like cellos now. And you can see there's a white dot in the middle of them, which is the average price for each neighborhood group. We can also see that in Manhattan, we have much more flats that have like high prices, so around £400, whereas the Bronx just really don't have many flats at all around £400. So this is another nice way of looking at our data. I'm aware that we have about 12 minutes left. So let's try and just get through this last little bit, and then you can have a go at this yourself. So can we plot the listings on a map? Of course we can. So the way we can do that is using this here. Now, this is just to show you the power of Matplotlib, of using pandas in itself, of using Jupyter Notebook, and we can use a scatter plot to do this. So first of all, let's just have a look at what that will give us. So we're going to plot the listings on the map. We're taking our new data frame that we made without the anomalies. We're calling plot on it, which we've done before, which is from matplotlib, which is preloaded with Jupyter Notebooks. You don't need to import it. We're saying that we want a scatter graph this time, and we're using the columns longitude and latitude that we haven't used yet, so it's good to use some more columns. Our dots that we're going to have on the map are the price, and they're going to be color coded with this Inferno color, and we're going to include a color bar, and then this is how big it is. So let's copy this over. This is just to show you the power of Matplotlib, of pandas, of everything that we've used today. And bam, we have our nice color bar down the side. You can see that the 500-pound flats scattered about, sort of focused over here. And then we have lots of purple, so much cheaper flats all around. And this is based on longitude and latitude. So it's actually where they are on a map. And you can see here that there's a big expanse of white space, which is most probably, and I know because I've again done this before, so I know what it is. It's Central Park in New York. So you can see where the different flats are based with Central Park over here. So big expanse of land that has nothing, has no flats on it at all. We can level this up. We can take this to the next level by using some code that I've pre-written that will then show it on a superimposed map. So if I copy this actually and show you what the map is here, we have this nice PNG image of New York, and all we want to do is superimpose our data that we have on top of this map. And I can do this with some pre-written code just to show you the power of what we can do. And if we run this, we have this beautiful map with our Central Park over here on the left and all of the flats around with our color bar. So we know the most expensive flat, the least expensive flat. And that is pretty much everything that I want to show you today. So there are a couple more slides on here which show you topics for that you can take your knowledge on data science even further. Learning SQL is super useful for data science. So if you've never seen SQL before, that is quite a complex query, but you can learn more basic SQL and that will stand you in good stead for a start off in data science because you use SQL a lot. You can also look at fetching data using APIs and requests, and look into web scraping too is really handy. And Wagon has all of these are webinars run by Wagon as well. If you're interested, they're completely free. And then the final step would be looking into machine learning. And if you're interested in machine learning, then you definitely want to have a look at our data science bootcamp, which is on our website, so www.lewagon.com. And if you do /London, then that will take you to our London website, and you can look at the course content. You can book in a phone call with my colleague Harriet, who can give you all the information about Wagon that you need. And then Alex or Laura in the YouTube chat will have sent you the link to the Learn platform as well. So let me just show you the Learn platform because it's really cool. So if I just go, where is the one that I need for you guys? If I go to, sorry, I've done quite a few of these. There we go. You will just have one on here, so don't worry. Or if you go to the link and click on it, all you need to do is just type in your email and create a password so that you have your own personal login. And then you'll have instructions to click on a notebook session. I'm just going to get the link for you now. I don't think we necessarily have it, so let me sort that out. Let me go back to this slide so you can have a look at that. So you have all of the information there on how to find how to open the notebook, and then you can go to your turn, and we have some challenges here for you to do. I'm just going to get the link so that you don't miss out on this, because that would be not fun. Here it is. And I'll send that through to Alex and he can share it with you. Okay, so you've got these challenges that you can do. This is a CSV file that you can download. And you can submit your work to us here because we love to see your work if you would like to. Otherwise, you can just keep it for yourself and practice on Jupyter Notebook with any CSV file that you find online. You've got some key takeaways. So you've got a little quiz here. Also, in this lecture, the top one, I don't think I showed you because I was looking for the link, but you have all of the slides that I've just done. So this is literally where I got the slides from. So they're no different at all. And you've also got a pre-recording of this guy here, who is our CTO, Seb Saunier. So he knows a lot of information about programming, data science. So he's your man if you want to go back over this. Maybe you can pause it as well as you go if you'd like to do that. So thank you all so much for having me today. It's been an absolute pleasure and I hope that you've enjoyed it. And I see Alex is back. Nice to have you back.
Thank you very much. I just wanted to say a big thank you to you as well, Sarah. I know it's a lot of time to go into that. I certainly enjoyed it, so I hope everyone else did as well. I've added all the links and stuff so they can go back and do this and check out some Wagon boot camps as well because they are great. So yeah, thank you very much for your time, everyone.
Thank you.
Bye.